tell me your doubts. Let's begin. From exercise 9.6, write them, tell me your doubts. We'll take them. Okay. Yes, Anaya, you can start. Hello. Edric, do you have doubts in this exercise? You can ask me. Abraham, any doubts?
Ma'am, can you just give me 1 minute, please?
Just that back.
Okay, sure.
I'm just trying to fix something in my tablet.
Okay.
8892.
Yes, Anaya.
921416 again.
Yes.
Hello. Yes, Anaya. You can let me know your doubts for the exercise 9.6.
Yes, ma'am. Just give me a minute. I have 3 doubts in exercise 9.6.
Okay.
It is. Yeah, it's question number. It's question 1, parts 1 to 3.
1 to 3.
1 to 3.
Okay.
Yeah.
Rest it's clear.
9. Yeah. Rest is clear, ma'am. It's, in text questions 9.6. Question 1, parts 1 to 3.
1 to 3. Okay. Can you tell me the values?
Yes, ma'am.
Joe.
Yeah, the principal is 16,000.
16,000.
Rate is 10%.
7%, 10%.
10%, yes. Time is 1.5 years. Compounded half yearly. Yes, yes.
Compounded half yearly. Okay. Okay. So, in this question, we have to find out both the simple interest and compound interest, and then we will do its difference. Okay. Because usually, the compound interest value is higher, so we subtract simple interest from that. Okay. So let's calculate the simple interest first. SI. What's the formula? TRT by 100. Use that. TRT by 100. Okay, then you put the values. Principal is how much? 16,000. Rate is how much? 10. Into time is how much? 1.1. Okay. So now this sign 1.5 it is. So I can remove this point, remove this, and I can put 10 and 100 it was. 100 into 10 I can put. Okay, I can remove the point and put.
Ma'am, could you
10.
just wait 1 minute? I'm just copying this. Just give me a minute, please.
Okay. You can cancel the zeros. And then multiply with what we are left with. Okay, that's 160 and 50. Okay, multiply them. Is
Hello, I
fine.
can't really hear.
Now am I audible to you, Simeon?
Now you are.
Okay, all right. So we have SI, okay, and now we gotta calculate the CI, okay, that is compound interest. So we will calculate the compound interest, first the amount, and then we subtract the this thing, principal term, okay, to find the CI. Okay, so let's find the CI. A equals to E 1 plus R by 2 by 100 to N. Okay, so now I can put the values. 1.5 years my time is, okay. And this is N, okay, and in half yearly we multiply with 2. So 1.5 into 2 is 3. So our power becomes 3. Okay, and our rate is 10, and in half yearly compounding half yearly we divide by 2, so our rate becomes 5. Okay, so write the values 16,000, one plus 5 by 100 raised to the power 3. Okay, now 5 by 100 you will calculate, you will take the LCM to calculate, you will get 105 by 100. Okay, you will get 105 by 100. You can cancel them. Okay, we can cancel the 5. 2s are 10 and 1s are 5. Then here 20 raised to the power 3. So you can write 16,000. 21 by 20 raised to the power 3. Okay. Then we will open it. Twenty-one by 20 raised to the power 3. So we can open it and write 16,000 multiplied by 21 by 20 into 21 by 20 into 21 by 20. Okay, cancel the zeros. 0, 0, and 0 with 0, 0, and 0. Okay, now cancel the 2's with 16. 2 1s are 2,
8.
8, 2 1, 4, 2 1, and 2. Multiply 21, 21, 21, and 2.
Ma'am,
Yes.
wait, where does it keep? I forgot it. Okay, ma'am. Ma'am will get 18,522.
Very good. 18,522 we will get. Okay. Now you found the CI equals to 18,522 minus 16,000. Okay.
Ma'am, it is 2,522.
Very good. 2,522.
Ma'am?
Yes.
And the difference is 122.
122. Okay. Good. Difference is 122. Okay. So CI equals to 18,522 minus 16,000. That is 2,522. Okay, then here writing the difference part. Difference equals to CI minus SI. CI is how much? 22522 minus SI is 2400. Okay. So your difference will be 122. Okay. This is your answer. Okay. So first we calculate SI, CI, and then find out the difference. Okay. Clear, Anaya?
Yes, ma'am. Thank you. Just give me a minute. I'm just copying it down.
Okay. Okay. No problem.
Ma'am, did you get 2,522 by subtracting 18,522 by 16,000?
Yes, yes, Amaya. I subtracted 18,520, 16,000 from 18,522.
All right, thank you. I'm done.
Okay. Rest of yours written, Abraham Simeon.
Yes.
Okay. Abraham done. I'm going to clear the screen.
You're going to subtract the CI and the SI, no, ma'am?
Yes, please subtract the SI from CI. Okay.
The answer is 122.
Yes, 122 is your answer.
Thank you, ma'am.
Yeah. Okay, so what was the doubt in the second one? Yes, Anaya. This is the same as the previous one, Anaya. What doubt you were getting in it?
Also able to solve either of them.
Okay. Edric, what were you getting in the answer of this? The difference? Half yearly. So in simple interest also, it will be divided by 2, okay? 20 and your minus 6 months, which is again compounded half yearly. So multiply them.
Hmm, 1,200.
Yes, 1,200. Okay. Now we will find out CI. First calculate amount. I by 2 by 100. Ten by 100. This becomes, par becomes 1, okay? Because 0.5 into 2 we will do, okay? 2n means, writing here, means 0.5 into 2, which becomes 1, okay? So 12,000 into 110, okay, take LCM, we'll get 110 by 100. Okay, so we will cancel out the zeros. We will have 13,200 multiply 13,200. Okay. Now find the CI. A minus B 13,200 minus,
Ma'am,
yes,
ma'am, it's 1,200.
yes. The CI, right?
Yes, the CI.
Yes, 1,200. Okay. Now we will find the difference, which will be what?
Ma'am, 0.
Yes. Sorry. It will be 0. Okay. Zero zero minus 1200. That is 0. Okay, so in this question, our CI and SI are equal, because of which there is no difference. Even if we go for the simple interest or we go for compounding, it will be same. Okay, difference is 0.
Ma'am,
Yes,
ma'am, you wrote CI equal to 13,200 minus 1,200. Ma'am, it should be 12,000.
12,000. Yes, so sorry, it is 12,000.
Ma'am, it's a red color. Change it to black.
Yes, yeah, it's 12,000. Written, and I have here. Abraham, any question?
No, ma'am, no
I'm
question.
still writing. Just give me a minute.
Okay, okay.
Sorry, it just went off. I'm still copying. Please don't erase.
Okay, Samir, okay, no problem.
Done, ma'am. Thank you.
Okay, Samir, just let me know once it's done, okay?
Okay.
Next week will be, yeah, yeah. Next week will be the test of compound interest chapter, okay? Next week, there will be test of simple interest and compound interest chapter,
I'm done.
chapter 9.
Ma'am, you said the science test, the science quiz was on Thursday, right, ma'am?
Yes, yes, ma'am.
I'm not available on Thursday.
Okay,
Church is doing a camp like sort of thingy, and I have to go for that soon.
okay. So, your mother told me about it, ma'am, and I'll update you, okay? I think I'll be shifting it to Friday. All right.
Okay,
So, yeah. Okay.
thank you.
Abraham, are you there on? No problem. Abraham, will you be able to attend the classes on Friday? You're free, right? If we shift the quiz to Friday, is it okay? Hope I'm audible to you. Maybe he's not getting my audio. This question also, Anna.
Yes, ma'am, this one as well.
Okay. And compounded, it is being compounded yearly. Okay, so first find out the SI. SI, CRT by 100. Five thousand, 10, 200.
Ma'am, is it 1,000?
Yes, Edric, it's 1,000. 1,000. Okay. Now we'll find out the CI. Amounts. Principal 1 plus I by 100 and 5,000. 1 plus R is 10 by 100 raised in the power 2. So 10 by 100, 1 plus 10 by 100, we know becomes 110 by 100. 5,000. 110 by 100 raised to the power 2. Now you can expand it. 5,000 into 1110 upon 100 into 1110 upon 100. Okay, now cancel.
1 second.
Yes, Sonia. Okay, or you can directly cancel here also. So here it becomes 11 by 10 and 11 by 10. Okay, like this also you can reduce. So 0, 0 and 0, 0. Okay, now multiply.
Ma'am?
50. Yes,
Ma'am, is it 6,050?
yes. 50 into 11 into 11 will be 6050. Okay, 6050. Now find the CI. Okay, that is amount minus principal. So 6050.
1060, ma'am. Sorry, 1050.
Ma'am,
Yes,
and the difference is 50.
difference is 50. Very good. This is 1050. Difference is 50. Very good. Compound interest minus simple interest. $50. Okay, like this we solve. So here we finished with all the three parts of the first question. Any other doubts? Anyone? Anything else you wanna ask out from this exercise? Abraham and okay, now great. Abraham and Simeon, any other doubts?
Can you explain this
Yes.
math? It's because
Which one?
something happened to my internet, so I was not able to listen to you, ma'am. Can you just explain this entire sum again, please, ma'am?
Okay. So this question we had to find out what is the difference between the compound interest and simple interest. These were the values which I was having. Principal was 5,000, rate was 10%, time period was 2 years and compounded yearly. Okay. So this is the SI formula that we used. SI equals to PRT by 100, as we know. So you put the values in the SI formula. PRT 5,000 into rate 10 into 2 time divided by 100. Cancel the zeros and zeros. Multiply 50 into 10 into 2. So you will get 1,000. Okay, so this is my simple interest. This is my SI. Okay, now we have to find the CI. So for CI, we first find the amount, that is P 1 plus R by 100 raised to the power n. Put the values 5,000, 1 plus 10 by 100 raised to the power 2. Okay, then LCM you will take of 1 plus 10 by 100. So you will get 110 by 100. Cancel the zero there, cancel the zeros. You will get 11 by 10. Okay, then you can expand it. Here you will get 5,000. Then 11 by 10, because you cancel the zeros, raised to the power 2. 2 means write it 2 times. So you've written it here 2 times. Now cancel the zeros again. Okay, and you will get 6050. Multiply 50 with 11 and 11. You will get 6050. This is my amount. Okay, now we know how to find the CI. Amount minus principal. 6050 is amount. Subtract my principal of 5,000 from it. You will get 1050 as my CI. Now, difference, how do we take? CI minus SI. So, 1050 minus 1,000 and 50 is my difference. Okay, this 50 is my difference. Clear now?
Yes, ma'am. Please.
Okay, written?
Yes, ma'am. Written.
All right. Okay, so any other doubts from this exercise? Anything else? No? Okay. So this we have finished with compound interest chapter.
Ma'am,
Yes,
one
Abraham. Yes.
little question on how to find the CI, ma'am, or when to how to like. Sometimes you have not you have split them. Sometimes you have not split them. I'm having confusion in those steps.
Sometimes you split them and sometimes you don't split them.
Yes, ma'am. I'm having confusion in the order of the steps and how to find them.
So when we are talking about CI, your first step is find amount. Okay, you find amount. All right. So for amount, you have three formulas. Okay. When it's compounded yearly.
Now, which question is this?
This is not a question. I'm just explaining him the concept, okay, of CI.
Okay.
Yeah. So you have principal 1 plus rate by 100 raised to the power n. Okay. Then half yearly.
Is this also exercise 9.6?
No, Simeon, this is not 9.6.
Because it
This
was
is just the concept, okay, of CI. Okay. When you're having half yearly, you put 1 plus R, you divide the rate by 2, then the whole thing by 100 raised to the power 2n. Okay, and then you have quarterly. Please don't erase whatever I have written. Principal, 1 amount, rate, by 4, I 100 raised to the power 4n we do. Okay. Now see what you were asking, that sometimes we expand it and sometimes we don't expand it. What happens? You have to multiply your number of years with 2 when compounding is done half yearly. Okay, and with 4, the number of years with 4 when compounding is done quarterly. Okay, this we know. Okay, this we know. Then what we will do? See,
Is
if
the
it's
n 3n?
yes, Abraham.
When it
Yes,
says
Abraham.
n, when will that part come?
When it says n in
No,
the question, then
3n.
3n.
Yes, ma'am.
Okay, it will not say 3n. It will be 2. And suppose in my question, my time is given 3, okay, and it's compounded half yearly. Okay, and my R is suppose 20%. Okay, suppose my R is 20%. Time is 3 years. Okay, this is compounded half yearly. Half yearly. Okay, so what I will do, I will divide the rate by 2, that is 20 by 2 by 100. And here what I will do, outside 2n. N is 3, 2n. Okay. Means that in half yearly, okay,
Yeah, actually, ma'am, if you're writing anything, ma'am, I cannot see it on the whiteboard, ma'am.
now can you see?
Ma'am, I can see, yeah, ma'am, now I can see. Ma'am, now I can't see again.
Abraham,
Ma'am,
start dragging your screen.
ma'am,
Yes.
ma'am, for half yearly and quarterly, you switch places for P and A.
Yeah. I think that's because it got
Ma'am,
dropped in the middle.
ma'am, I have a doubt, ma'am.
It got, yes.
Ma'am, can you find the first compound interest without finding the amount?
This is just an example, okay? This is an example that I've taken, okay, this is an actual question. All right, this is to explain him how the power works, okay? How the power thing works, all right? How this thing is working, all right? So it's not an actual question, okay? It's just an
Ma'am?
example. Yes,
Ma'am, tomorrow what are you teaching, ma'am? Tomorrow?
new chapter we will begin.
New chapter? Chapter 10?
Chapter 10, yes, that's right. Okay, chapter 10 we will begin tomorrow.
When's the test for this
Okay.
chapter?
Next week, compound interest test is
Friday?
next week.
Friday?
Next week I'll let you know then, okay?
Okay,
When
ma'am.
I'll let you know. Okay,
So
so
the
Ma'am?
science, is there a science test this week?
science quiz this week, okay? On I think on Friday I'm planning. It's postponing it to Friday because Anaya won't be able to attend on Thursday. And I really want you guys, all of you all to attend. Okay.
ma'am.
So, Abraham, is it okay on Friday?
Yes, ma'am, but I have a question, ma'am.
Mm-hmm. Yes.
Ma'am, what are the tests for this week? Biological processes 1 and 2, right?
Only science quiz.
Only science quiz, ma'am.
Yes. Chapter 6 and 7. Materials and its types.
Ma'am?
Yes,
Ma'am, time up.
I know. Okay, Abraham, hope you got it. How we compound everything.
Ma'am, I kind of got it, ma'am, but I still have a few doubts. in compounding.
Okay, so I will continue this in the further classes, Abraham. Okay, I'll show you. Yes, I'll show you a more quicker and easier way to remember this concept. Okay, we'll split it and we'll learn it. All right. I'm
Yes, ma'am.
stopping right here. Okay, but I'll take this up. Okay, in the further classes, I'll show you a way easier method to finish.
You show what?
Um, simpler method to learn the concept of compound interest. Okay, we split the terms and we learn it.
Ma'am?
Yes, ma'am, thank you.
Okay, so that's all for the math class today. See you all. See you, Edric, tomorrow.
Bye, ma'am.
Bye. Bye. Science class we're having in the next 5 minutes. So 5 minute break and then we'll continue. Okay.
Thank you. Bye, ma'am.
Okay. Okay, I hope you heard that well.
Yes, ma'am.
Okay, that's great. One second, let me share my screen. Okay, so in the last class we finished till biological changes. Right?
Ma'am,
Today
this
we
is
will
chapter 8, right?
yes, chapter 8, how do changes takes place. Okay, so till biological changes we did. Now we'll do the rest. Okay, that's slow and fast changes. Okay, now there are some changes, okay, that are slow to take place and some changes that are very fast to happen. Okay, this is dependent on its pace, like at what pace the change is occurring. Okay, at what pace the change is taking place. For example, a man, a plane, a train, and a horse are running or flying with their full velocity. Can you imagine which of these is changing its place more quickly? Whose speed is less than that? Who will be the third out of these? Who is the slowest? Okay, so a plane will be the fastest. Okay, to change its place. Okay, the change will be the fastest for a plane. Then it will be a train, okay, a horse, and then a man. All right. So like this, your changes takes place. Now, this is also a good example. When we burn a fulgari and a candle simultaneously, both will burn. Okay, but the fulgari burns very quickly. Right? If you have a light in a one, lighted a one, this burns very quickly, but a candle burns slowly. Okay, candle it burns very slowly. The wax melts at a slow pace. So this is another example. Okay, so some changes happen really quick and some changes happen very slowly. Okay, then we have desirable and undesirable changes. Okay, means good and bad changes. Desirable are the good ones and
Like what you
undesirable.
want and don't want.
Yes, what you want and don't want. Okay, some things can be there which we want. Okay, but it might not be good for the environment. Suppose, for example, firecrackers, bursting of firecrackers. Okay, people feel good, they like to do it, but that's bad for the environment. Okay, that's not good for the environment. So this is can be a bad change. Okay, then the cutting of trees. Okay, to make houses and all is good for the humans, but it's bad for the environment again, for the habitat of various plants and animals living there. So it's again a bad change taking place. Alright, so these are what good changes and bad changes. Okay, you have to see what's the ultimate effect of that change. Okay, what's the overall effect of that change that's taking place? Is it actually good or bad? Okay, so that will be a good or a bad change. Now, can any change be stopped? Some changes can be stopped, yes, but some changes cannot be stopped. Okay, like like the day and then the day turning into the night and then the night again turning into the morning. It's a change that we cannot stop. Right? We cannot stop the sun. We cannot stop the moon. All right. But some changes can be prevented. Like a burning wood or a candle be prevented from burning? Can we prevent it? Yes, we can prevent it. Okay, so some changes can be prevented. Iron can also be prevented from rusting by applying paint, oil, grease, etc. on its surface. So it can be avoided. Okay, this change can be avoided or prevented. So like this, some changes can be prevented and some cannot be. Then interaction among changes. When a bird flies in the air, it pushes air from its wings. Air opposes to flying. The resistance of air helps the bird to fly. Thus, the body of the bird and the air interact with each other. Okay. Then, when you pour water on quicklime, it undergoes a chemical reaction. Reaction between calcium dioxide in water results in the formation of calcium hydroxide. That's lime water. Okay. That is two things. Okay, are coming together. Okay, and then forming a change. Okay, it's forming a change. Right. That's interaction among changes. Okay, you can see 8.2 you can see today at home. Okay, yes, you can check out. Then we have types of chemical reactions. Okay, this topic is really important. All right, types of chemical reactions. Now there are a lot of chemical reactions that takes place. Okay, and how are they different from each other? Okay, because of their result. Okay, because of how the reaction is taking place. All right, so this is combination reaction. For example, I have an element A plus I have an element B gives me what? Combination of AB. Okay, you can note down these examples. This is known as combination reaction. Okay, this is known as combination reaction. It's formation of new substances by the combination of two or more substances. It's known as combination reaction. Okay. When a substance burns in the air, it combines with oxygen present in the air. Okay, so that's also an example of combination reaction. Okay. This is also an example. CaO, that is quicklime, plus H2O, that's water, gives CaOH2, that's quicklime plus heat. Okay. When you add water to quicklime, it gives you quicklime. Okay, this is also an example of combination. This CaOH2 is combination of quicklime and water. Okay, so that is why this is known as
What's
combination.
slaked lime?
It's basically a mixture of your lime and water. Okay, of your quicklime and water, right? So that's CaOH.
I didn't understand.
Quicklime, Simeon. Quicklime and water. Okay, when you add water to the quicklime, it becomes slaked lime. Okay,
So then slaked lime, how does quicklime plus water equal slaked lime plus heat?
okay. So when you are adding, this is my quicklime, and when I'm adding water to it, slaked lime also gives some heat. Okay, some heat is produced in this reaction. Okay, in the last chapter, when we were studying that when a reaction is taking place, there are some elements, okay, that is produced with the like the effect of that reaction, as the effect of that reaction that's taking place. What were they? Sometimes heat is produced, sometimes the sound is produced, sometimes smell is there. Okay, sometimes there is this thing. It's like a fire. Okay, that's heat. All right, then sound or smell. Okay, those are the elements which are produced when a reaction is taking place. So heat is that element, okay, which is also produced when the reaction of quicklime and water is taking place. Okay, in the combination reaction. This is a resultant of it. Okay, in the resultant, this is also produced with slate line. Okay, this is slate line. Okay, 1 minute. To see
If you're saying anything, I can't hear you. No, ma'am, I can't hear you. You're on mute.
okay, right. So CaCO3. Yeah, the image that was showing, I think I was mute, that was of slake lime. Okay, that's how slake lime is like when it's mixed with water. Okay, and this decomposition reaction, this is like the opposite of combination reaction. Okay, in combination we combine two things. Okay, and a new thing is formed. In this one thing breaks down into two things. Okay, suppose I have CaCO3, so it becomes CaO3. Okay, O3.
I really didn't understand that part.
Okay, it's nothing singing basically. You just have to remember that quicklime is a substance, okay, CaO, okay, and when you mix water to it, there is H2O, okay, it will give you CaOH2, okay, that is slate lime, okay, CaOH2. Now, how it's happening? See, if you look here closely, 1 minute. See, CaCaO plus H2O. Okay. Now, one O is there in this one. Okay. And one O is there in this one. How many O's are there?
And there are two
Two.
H's also. So you basically
There are,
just did Ca outside and OH inside and then 2 outside. Like to the power of
yes. Yes. So Ca outside and O is common and H also 2 we have and O also 2 we have. So we can write OH inside and 2 outside. So this is what? This is slate line. Okay. This is slate line that we formed. Okay. So this you have to look for. Okay. This you have to keep in mind that it's forming slate line. Okay. Now decomposition reaction. One thing breaks into two. Okay. A substance breaks into two. All right. That is CaCO3 is there. So it will break into CaO. O3 means 3O it has. So one O is here. Okay. Ca and one O here. And then I'll be left with this one O. It came on this side. And I'll be left with C and O, two O's. So CO2. That's carbon dioxide we know. Okay. And CaO is quicklime. Okay. This is quicklime. We know. And this is carbon dioxide. Okay, like this you can break them. This is carbon dioxide, you know. Okay, so like this we can break them. All right. This is decomposition reaction, in which a single substance breaks down to give two or more substances. Okay, then we have displacement reaction. Okay, displacement reaction. When an element displaces another element from its compound by a chemical activity, a displacement reaction occurs. Okay, when an element displaces another element from its compound by a chemical activity, a displacement reaction occurs. Okay, so let's see an example of it. Okay. A, G, N. This is Ag and NO3 I have. Okay. Plus I have two more. I have Na. Okay. And I have Cl. Cl. Okay. So this goes with here. Okay. And this comes here. Okay. This reaction takes place. So what I will get? Ag and Cl plus Na Na and NO3. Okay. So this thing, this Ag has displaced it here, okay, and this has displaced it here. So what I have got is AgCl plus NaNO3. Okay, this is known as displacement. See, this element is displaced from its compound, okay, and here this element is displaced from its compound, okay. Na and Cl are compounds, Ag and NO3 are compounds, okay. It's being displaced from its original compound. Okay, so this is your displacement reaction. Okay, this is your displacement reaction. All right. You can write this down if you want.
Ma'am, will this displacement reaction, how it happens, come in the test?
It can come in the test. Okay. It can come in the test. All right. Such reactions in which there is an exchange of ions between the reactants are called double displacement reactions. Okay. In which there is an exchange of ions between the reactants are called double displacement reactions. Okay. So this can be an example of double displacement. Okay. There is also single displacement reaction that takes place. Okay. Single displacement reaction is also takes place. Okay, this is an example of a double one. What happens? Suppose I'm having, let's take an element A, okay, plus element B and C. We have, okay, element A plus element B, C. We have. So what happens? This A, okay, gets here, so it becomes reaction A, C, okay, plus B. Okay, it's displacing it here and we're getting A and C plus B. Okay, so this is how single displacement reaction takes place. Okay, so then there is redox reaction. You have learned that if a substance gains oxygen during a reaction, it is said to be oxidized. Similarly, if a substance loses oxygen during a reaction, it is said to be reduced. It means during this reaction, one reactant gets oxidized while the other gets reduced. Okay, that is one reaction gains oxygen. Okay, and the another reaction loses oxygen. Okay, one reactant gets oxidized, that gains oxygen. The other one, in it the oxygen gets reduced. Okay, this is known as redox reaction. In all redox reactions, one compound gets oxidized while the other gets reduced. Reduction is not possible without oxidation, and oxidation is not possible without reduction. You will learn more about this in the higher classes. Okay, so this is a redox reaction, and in this reaction, one element, suppose this is reactant A, and this is reactant B. This is my oxygen. It gains it and it loses. Okay, one element gains oxygen. Okay, so this is um known as oxidized. Okay, and this is known as reduced. Okay, this is known as oxidized and this is known as reduced. Okay, so I'll be sharing with you notes for this part, okay, with all these reactions. Okay, because good examples and good reactions are mentioned. So we'll be sharing good reactions, okay, from this topic. Then we have acid, bases, and salts.
Can you just show the reaction, the last one?
Last one. This is not a reaction, this is an example, okay, of what actually happens in a redox reaction.
Yeah.
This is an
Okay,
example. Yeah.
Ma'am, also another thing is, will you share the reactions in the group or we'll have to copy it now?
I'll be sharing the reactions in the group.
Thank you, ma'am.
Yeah. Okay. So acid, base, and salt. Now, the nature of chemical substances is acidic or basic. Okay. Have you seen a litmus paper? A litmus paper is used to check if a thing is acidic or basic. Okay, it's used to see if something is acidic or basic. Litmus paper is known as when we were, I think, in our 10th standard, we used to go in lab, prepare various kinds of solutions, like a soap solution and like some more solutions, okay, like lime water and like that. Then we used to take the litmus paper and dip it into it, okay. So it is of yellow color originally, okay, it is of yellow and it changes its color to blue or red. Depends on if it is acidic or basic. Okay, it changes color to blue or red. You can try out. Okay, to with litmus paper. Okay, you can prepare solutions and check if they are like acidic in nature or basic in nature. Okay, so it used to change color and it was so fun to do it. Okay, so yes, so that's how like things are acidic in nature or basic. Okay, now curd, lemon juice, vinegar, tamarind, taste star. These substances taste star because they contain acids. The chemical nature of such substances are acidic. Okay, baking soda is bitter in taste. If you rub the solution between fingers, it feels soapy. Substances like this, which are bitter in taste and feel soapy on touching, are known as bases. Okay, these are bitter in taste and it feels soapy to touch are bases. The nature of such substances is said to be basic, but they are substances which are neither acidic nor basic. Okay, they are neither acidic nor basic. They are known as neutral substances. Okay, Neutral substances are neither acidic nor basic. We cannot taste every substance to check whether it's acid or base. And how do we find its nature? Special types of substances are used to test whether a substance is acidic or basic. These substances are known as indicators. Okay, so now these are natural indicators. Okay, naturally occurring indicators to test if something is acidic or basic. Means that these change their color when added to a solution containing acidic or a basic substance. If you add turmeric to an acidic or basic substance, it changes color. Okay. Litmus, okay. China rose, petals, good health, etc. Some of the naturally occurring indicators. Taste the following substances and enter the results. Okay, so you can try them out with the guard lemon juice. Okay, you know how they taste, so you can just fill in the table. Okay, this is the paper that I was talking about.
Ma'am,
Yes.
when I homeschooling group with Mumbai had a science exhibit, ma'am, I was preparing on acids and bases.
Okay. Then what did you learn in it?
Ma'am, I learned that some bases are some are neutral, some are acidic, and some are basic. So to test them, you can use a pH universal indicator to know the exact pH. And if you want, for water, you can test. You can use a pH. You can use a pH meter, a device that can check the pH.
Okay, that's right. So we can check the pH of the things. Most commonly used natural indicator is litmus. It's extracted from lichens. It has a purple color in distilled water. When added to an acidic solution, it turns red. When added to a basic solution, it turns blue.
I've also checked in one of the. I also checked the pH of water with a universal indicator and an experiment.
And then what happened?
So when you as soon as you put the universal indicator, you have to put the cap on it, the test tube, and you have to shake it. Then after something, then in a few seconds you'll see like a different color, and then you can check it on the pH scale. So I did.
Okay, that's right. So pH scale is also there, like it's on a pH scale, like colors are there. Okay, you have like a strip, okay, it's divided. Okay, and then there is very dark red, then slightly lesser, and then slightly lesser, and then like that. Your pH color test is like that. Okay, like that. The color of the strip, you have to match it with this main strip to check what color, what's the scale, the pH scale it is. Okay, so like that, it's tested. It's available in the form of solution, in the form of strips of paper known as litmus paper. Okay, acidic turns blue litmus to red. Okay, if it is acidic, it will turn red. If it is basic, it will turn red litmus to blue. Okay, this is how we know that something is acidic or basic. Okay, then we have turmeric. It's natural indicator. You can try this out activity. Okay, make turmeric paper by decompositing turmeric paste on blotting paper, filter paper, and drying it. Okay, so this is actually a good activity if you try out. Yes, you can try this out. Okay, try this out at home and send me the pictures. Okay, try this out and you can share the pics with me. Okay, do what? Do this, like take a blotting paper or filter paper. Okay, make a turmeric water. Okay, and then dip it into that water. Okay, turmeric paste kind of thing, turmeric water. Dip it and leave it for some time. So you'll have a yellow paper. Okay, have a yellow paper. Cut it in strips. Then put it into soap solution. Okay, you can prepare a soap solution and you can dip the turmeric paper in it. It will turn red in color. Okay, it will turn red in color. Alright, so you can try this out. I've tried it when I was a kid. As a kid, I've tried this activity. So this you can try. It's a natural indicator. Then we have China rose. It's also a natural indicator. Okay, it's another activity. You can take good health petals and place them in a beaker. Add some warm water. Keep the mixture for some time till water becomes colored. Use the color water as an indicator. Add 5 drops of the indicator to any solution to see the effect. China rose indicator turns acidic solutions to dark pink and basic solutions to green. Okay, you can try this, adding this China rose. I think hibiscus it is. You can try it out with. And then it'll turn acidic solutions to dark pink and basic solutions to
China rose is the hibiscus flower, right?
I think so, yes. Okay, so from neutralization, we will start from the next class tomorrow. Okay, we are going to study the reactions and the example of neutralization. Okay, and then the chapter is over. So tomorrow this chapter will be over. We'll start with a new one, okay? All right, so the quiz will be on Friday, okay? Friday this week, and I haven't kept a match test this week, all right, because we haven't done any backup. We didn't do any backup class, and we just got over with the compound interest. So we can take a little break from the compound interest, okay, but keep revising. All right, next week we'll keep the test of compound interest chapter.
Next week will the compound interest chapter be done, you said, or is it the science thing?
Next week, compound interest chapter is over, Simeon, and next week I'll take its test. Okay, and I think science test will also be there. Biological processes 1 and 2. Okay, so please prepare well for the quiz. That's all for the class today.
Ma'am,
See you
so we're doing
tomorrow. Yes, Simeon.
so we're doing biological processes chapter later on after we do the materials chapter.
Yes. Next week is the biological processes 1 and 2 test, both. Okay.
Okay. But why is it like that, ma'am? Doesn't biological processes come before the materials?
Yes, but I took the materials one before because I wanted to give you all more time to prepare for that mega test. Okay, so I kept a quiz in between. Okay, so I kept this quiz in between. It's very interesting. We'll give you a break from all the tests on test series. Okay, it's gonna be fun activity. So that's it. See you all tomorrow. Bye. Bye guys. See you all tomorrow.
Bye, thank you.
Bye, ma'am.
Okay, okay, man.
See you tomorrow.